Wasfeld. Hey, this is Wasfeld. Let's get going. Quiz 29. A kid holding a baseball bat stands at rest in a small boat. So here's a small boat. Here's a kid standing in it. Kid has a bat. And the boat's in the water, of course. And here's shore. And the mass of the kid and the boat is 250 kilograms. So someone on shore throws a ball. The ball has a mass of, you know what that is, right? 149 grams, right? So it's 0.149 kilograms. It flies straight down the length of the boat, reaching the batter at 20 meters per second. So 20 meters per second. And the boy hits it, the ball, with the bat, and the ball goes back the way it came at 20 meters per second. What's the speed of the boat immediately after the ball is hit? So what we've got is, are there any net forces on this system? So let's say my system is the ball flying at the boy on the boat. And the answer is, if my system is the boat, there's really no force on the boat that would keep it from going forward or backward, even if you threw a much larger thing at the boat and it fell on the boat. The boat would still go, so we're going to say that the net force, or the external force on the system, is 0. That is our condition for writing the conservation of momentum. So the change in momentum of the system equals 0. Because the change in momentum would be the force. The force is 0. That means that momentum initial of the particles is equal to the momentum final. And, well, this one actually meant that momentum final minus momentum initial was equal to 0. But I just took the shortcut of equating the two. So now let's talk about what the initial momentum of the system is. So I've got the boat, the mass of the boat, times the velocity of the boat initially, but the velocity of the boat is 0. And I've got the mass of the ball times the velocity of the ball. I should say that I'm thinking that this way is positive x, so positive velocity, positive direction. And so this was initial momentum. The final momentum, so let's write down what we think the mass of the ball times the speed of the ball is. 0.149 kilograms times 20 meters per second, and that's all positive direction. So that's something like 29.8, right? Or 0.298, or something like that. Final momentum. Final momentum is, all right, final momentum, you've got the mass of the boat times the velocity of the boat. Remember that the ball doesn't stick to the boat. It flies back off the boat, so we don't have to add that mass in. Some problems, right, with inelastic collisions, they stick together. And then you've got mass of the ball times the velocity of the ball. And in this case, the ball is going back the other way, so we have to be careful with this term right here. But what you've got is initial momentum. I'm working my way down here with this. So the mass of the boat is 250 kilograms times the velocity of the boat, which is our unknown. This one is like a question mark. And the mass of the ball is 0.149 once again. kg, and the velocity of the ball now is minus 20 meters per second. Okay. So let's see. I'm not going to combine those right here, right now. Some textbooks, they put a prime, like this is after the collision, so they kind of prime them, and instead of putting like all these crazy subscripts and things. So what we've got is 0.149 kilograms. This is the initial momentum of the ball times 20 meters per second. Plus that, we brought it from the other side. Divided by the mass of the boat. And that equals the velocity of the boat. And especially the velocity of the boat after. Okay, so how did we get there? We got there by putting this is initial momentum, and we set this equal to that. And then I rearranged some things. So if we plug that into our calculator, let's see here. Calculator. 0.149 times 20 plus, well, times 2 divided by 250 kilograms. So what's your guess? Is it big or is it small? Well, probably pretty small because the mass of the baseball was not that big. So here, the velocity of the boat after the collision, immediately after being hit, is 0.02384 or 0.024 meters per second. As a special hint for the next one, let's say the ball goes past the batter and is caught by someone on the boat. So what's the momentum of the boat after the ball is caught, and then what's the speed of the boat? Just you can run these equations and then figure out which term you don't get to keep, and then what changes about maybe the mass of the boat. Those are just some hints. Anyway, thanks for listening. That was quiz 29.